Okay, so today we're going to talk about linear transformations. And what linear transformations are is they are transforming the values of your x's by either multiplying or adding or subtracting from them and seeing what they do to the mean and the standard deviation. So let's take this table, and the first thing that we're going to think about is this distribution a discrete distribution or a continuous? Now, hopefully you said that this was a discrete distribution, and the reason we know that this is a discrete distribution is that these numbers aren't intervals. They're single numbers like 2, 3, 4, and 5. And so let's graph this distribution. And when we graph it, I want to know like the shape of it. And hopefully we know that the shape of this thing is symmetrical because it's pretty even on both sides. Like it doesn't really have much of a skew to it. So this thing is pretty symmetrical. And the next thing that we kind of want to do is we kind of want to figure out what the mean of this distribution would be. So hopefully you remember how you take the mean is you take this number right here and you times it by this number right here. And then you would take this number here and this number here and times them together. And after you've times all the numbers in the chart together, you would find the sum of those things. And you would find the sum of that would be 3.75. Then you'd find the standard deviation, which would just be this formula right here. Which would just be your xi value minus your mean squared times your probability, and then you'd have to square root the whole thing because this thing in here would be your variance. But we found our mean and our standard deviation. And so let's say we're going to transform that table. So the only thing I did to this table below here is, since these are the number of passengers, I'm just saying we're going to collect $150 per passenger. So if you had 2 passengers, that'd be $300. If you had that, that'd be $450. And so our new graph should look very similar. Now, if you think about what that should do, is that should just shift everything for the mean. So our shape doesn't change, so our mean should be in about the same spot. So it probably will be about 3.75 times 150. Because if I had 3.75 customers and I each got $150 out of them, that's about how much money I would make. And our spread's going to increase because these numbers got bigger. And so if you look at it, it really is just these two numbers times 150. So multiplication affects it by multiplying the spread by that term and multiplying the mean and the median and the quartiles and the percentiles by that term. It doesn't affect the shape though, as you could see before. Like these shapes still stayed the same, but everything else was multiplied by that. Now note that if we do this, the variance, since if the standard deviation is b times our other one, so let's call this b, like the standard deviation of y. If I wanted to find the variance, since I'd square this thing, we'd have to square this thing, so that would mean that the value you times it by would be squared. So just realize is like the variance isn't just times by b, it's times by b squared. Okay, so let's look at another one. So that's the same table, and that's what we got before for the mean and the standard deviation. But this, let's say that it costs him money to do all of this. So it costs him $100 to buy the permit, the gas, and the ferry, but it doesn't matter how many people he takes along with him. Like, I don't have to do 100 per person, I just have to do it per trip. So if he collected it from 300 people, well, we have to minus $100 from that. Same here, if I had 450, I have to minus 100. So let's see what minusing does. If you think about it, minusing should affect where this middle value is, but it really shouldn't affect the spread too much. And that's what we do get. Like, the mean is subtracted by 100, but the standard deviation stays the same. So the mean is affected and its subtraction, but the standard deviation stays the same. So we can make general rules for this thing too. Like it's going to add to the centers and locations. The standard deviation and the measures of spread and the shape will stay the same. So these two things are going to stay exactly the same. And so we can really do this and look at it like a line and say we're going to affect it by y equals mx plus b. And what that's going to do is whatever I times it by, or my slope, or that change right there, that's going to affect both my mean and my standard deviation. The b value is only going to affect my mean. Okay, so if we kind of see this, they give that general formula right there. Whoops. So yeah, so they give that kind of general formula right there. Let's see what a problem of this might look like. Okay, so in this problem, they say that we have a normal distribution with a center, or a mean, of 34 and a standard deviation of 2. So this would be at 36 and this would be at 32. Okay. And so we got this normal distribution, and they say, hey, what if I wanted to convert all these Celsius values to Fahrenheit? And this is how you convert it up here. So let's think about what that would do to our different things. So our mean would be affected by both the multiplication and the adding. So let's see if we can think about what our new mean would be. Well, my new mean would be 9/5 times 34 plus 32. And if we do that, we would get a mean of 93.2. Now my standard deviation is going to be a little bit different because it's not going to be affected by this adding. It's only going to be affected by the multiplication. So we would have 9/5 times 2, and that would give us 3.6. Now let's see, what's the probability that somebody gets between 90 and 100. So the first thing that we would have to do is we would need to convert those things to z-scores. So I'd have to take 90 minus 93.2 and divide that by 3.6. Find out what that z-score is, and then also do 100 minus 93.2 over 3.6. So about negative 0.89 for this one. Then 100 minus 93.2. Divided by 3.6. So about 1.89. Okay, and if I go back to my z-table, negative 8.9 would be this column right here, so it'd be about 19%. And we have to find positive 1.89, which would be right over here at 97%. And if I want to find the middle portion, I would need to take this thing and subtract it from this thing. So the percentage that I should get should be, well, %78. That's how I do one of those problems. Again, remember that adding is going to affect the mean, and multiplying will affect the mean, so both of those things affected the mean. But this adding right here is not going to affect your standard deviation. Okay, try the word problems today.